PDF. So I thought that there's really, in calculus 1, we don't need to cover every topic, okay? But the things we for sure have to cover are derivatives, which lead to integrals, and then in calculus 2, you're doing mostly integrals, but we can't jump right to them because they rely on derivatives. So mostly integrals. Okay, so I thought we'd just start with derivatives.
Okay.
And see, see where that goes. So the very first derivative rule that I'm going to give you, and it's not going to be typing the whole time, but derivative rule number 1 is the power rule. Okay, so so what that is if I give you, if y equals x to the n, okay, and we'll do an example over here. Like, let's say that y equals x squared. The derivative y prime is x to the n minus 1 power times n. Okay, so we don't need to worry about what this is or why this is, but we just need to know how to do it. So you subtract 1 from the exponent, so it's 2 minus 1, and then you bring this number out in front.
From where? Oh, okay.
From the exponent here. So this becomes 2x, or 2x to the power of 1.
This is the derivative?
Yes, this is the derivative. So so we're going to do a bunch of these power rule derivatives, okay? Until you get comfortable with it, and then we'll add some complexity. So let's say I tell you that y equals x to the 5th, x to the power of 5. Okay, so the derivative rule, you bring this number down.
5x.
5x to the 4th.
Okay.
Okay. So that's pretty clear. So that's an example here. Let's do another example. Let's say y equals x to the 3rd plus x to the 4th. Okay, so the derivative rule here is you do the same thing you did in the previous problem. So you bring this down. This is 3x squared plus, bring the 4 down, 4x cubed. Or 4x to the power of 3. Do you follow that? Okay.
Yes.
Great. So now we can do this with negative exponents. So y equals, let's say it's x to the minus 3. Okay. So the derivative is you bring this number down, minus 3x, but you're subtracting 1. So the power rule here, let me just bring it down here again.
So it's negative 4?
It's negative 4, exactly. Okay, so it becomes minus 3x to the minus 4. Now, this is where you get into your prerequisite stuff. Like, you might write it or see it this way, because with the negative exponents, it can go down to the bottom here. Okay, so these are the same.
Okay.
So you might see them this way. So here's an example of how you'd actually see it in your class. 1 over x to the 5th. Okay, and you might think, oh, well, I just apply the power rule. No, you have to actually rewrite this as x to the minus 5. Okay, and then now you can take the derivative. This is the derivative step. So this is where you bring that minus 5 down. It's minus 5x to the minus 6 power.
Wait, so how is the question? The question is...
what is the derivative?
For what? For 1 over x over 5?
Yes, yes. So you have to be able to take the derivative of everything. And that's this is the most basic thing that we can take the derivative of.
Wait, what happened to the 1 on top?
Well, you rewrite it. See how these are the same? This is the exponent rule here. This is the exponent rule, which is not calculus. It's if I give you x to the minus n, this equals 1 over x to the n. So this is something you learned before calculus.
Okay.
Can I keep going here?
Yes.
Okay. All right. So again, the example could be y equals x to the 10th plus 1 over x to the 9th. And it would be like, what is the derivative? What is the derivative? Same question always.
The derivative is 10x over 9.
10x to the 9th. Yep.
Yeah. Plus x to the power of -8.
So this right here is really x to the
-10.
minus. Yeah. So it's
-10.
minus 9 x to the minus 10.
Minus -9. Okay. Negative. Okay. So you bring the 9 up and bring it and make it negative.
Yes.
Yeah. Okay. Okay.
All right. So let's do another one here. So let's say we've got an example here of y equals x to the -11 plus 1 over x to the 10th.
How was the question?
Same thing. What is the derivative? That's all we're doing. Like we'll be doing that. I don't know how long, but you've got to be able to find the derivative for this whole thing right here.
Oh, okay. I'll do it. I'll do it right now.
Yes.
Equals. Okay.
Okay, so let me write the answer here. It's minus 11 x to the minus 12.
Yes.
Plus -10 x to the minus 11.
Yes, I got
it. Now you may also see it written this way in a textbook or in a web assign. Is that okay? These are the same. These are the same.
Oh, that's the same?
Yep, they're the same because of that exponent rule. Like you can write the -12 on the bottom as positive. You can write the -11 on the bottom as positive. And you've got to be able to like see either one. Use either one. Is that okay?
Yeah.
All right. All right. So let's move to a new rule. This is a new rule. Okay. So the rule is if I tell you y equals a constant times a function, the derivative, you keep this number, you keep this constant, and you take the derivative of the function. And I know I'll give a lot of examples, but I think an example just helps. Let me just jump right to an example. So let's say y equals 3x to the 5th.
Okay.
The derivative is you bring the 3 down, and then what's the derivative of this? What's the derivative of x to the 5th? We just did a bunch of those.
5x 4. Yeah.
To the 4th, right? Now these are multiplying here, so they're multiplying here. So you have to multiply these together. So that's 15 x to the 4th.
Okay.
Let's do another example. Let's say y equals -3x to the 3rd. So the derivative is, these are all, what is the derivative? What is the derivative? What is the derivative? You bring the -3 down, and then you figure out the derivative of this. That's 3x squared. So you multiply these together, and you get -9x squared. Is that okay?
So
So you always bring this
yes,
number in
yes.
front. You always bring this number in front. We're gonna do a bunch of examples. That's the power here. So it's 5x to the 8th plus 3x to the 4th. Okay,
I'll do it.
you try it. Give it a try here.
Okay. Yes, I did it.
All right, so here's the final answer: 40x to the 7th plus 12x cubed.
Yes, I got it.
Great. So now we're going to play this game of like, I'm going to give you the more difficult one. So let's say it's -3x to the -7 plus 4x squared. Okay, so try this one on your own, please. Sorry about that.
Okay.
All right. So here's the final answer here. Y prime equals 21x to the -8
Yes.
plus 8x to the power of
Yes.
1.
I
Great.
didn't put the power 1. Is
That's
it okay?
okay. That's okay.
Okay.
Okay. So now let me throw in another little wrinkle, another little modification. We haven't talked about this one yet. What is the derivative of 4x? Okay.
For x, it's
Yep.
0.
So it's 4 because you bring that down. You subtract 1 there and bring the 1 down, right? You bring that 1 down. So this is 4x to the 0. What is x to the 0?
0.
It's 1.
Oh, it's 1.
Yes. So the derivative here is just 4 because it's x to the power of 1.
Okay.
So see how I'm just adding in like a little wrinkle, a little change here and there, and that's what makes this tough. Is there's a bunch of these rules that you have to learn and be really fast at them. So let me give you another one here. All right, so here's your next example here. So let's say it's y equals 4x to the -5th plus 3x squared minus 2x. Try this one on your own, please.
Sure. Yes, done.
Okay, so I'm going to write the answer, and you can tell me if you got it.
Yes, I got it.
Great. Excellent.
And now I put it the exponent 1 for the x
That's fine.
6x1.
That's good.
Okay,
You
okay.
can do that or not. It doesn't matter. Okay.
Okay.
All right. So here's another, here's some other examples you might see. Okay. And it will say, take the derivative of this. Okay. Take the derivative of this thing right here. The problem is you're like, I don't know how to do this, but here's what you do know. You can divide each of these by x, 4x to the 5th over x minus 3x squared over x. And do you remember your exponent rules? If you have x to the n over x to the m, you subtract the exponents. Do you remember seeing that? And this is not calculus yet. This is just pre-calculus or college algebra. So like 5 minus 1 is 4. This becomes 4x to the 4th. And this becomes minus 3x to the 1. Okay, and that's this step here. Now comes the calculus, the derivative step. This line is just like what you were doing here. Okay, so you can do that line, but you have to make these changes first.
Which one? What changes?
This is what you're trying to do, the derivative, but it came from this line up here. Like we started here, and you had like you can't do the calculus until you get to this line here. So like this is college algebra, and then now we finally get to the calculus where you say, oh, 4, this is 16x cubed minus 3.
Wait, for why, for the second part, why did he put x
here
1, then the other one there's only x?
It can be x1. I'm sorry. I'll be more consistent. I'm sorry.
Okay.
Okay. All right. So let's do another example here. Let's go y equals 5x to the 8th minus 3x to the 7th over x squared.
I'll do it.
Yes, you try. It's just like the previous one. You're going to write this and then do some derivative stuff.
Okay. Okay.
All right. So when you divide each of these, 5x to the 8th minus 3x to the 7th, you get 5x to the 6th minus 3x to the 5th. And from here, okay, you can apply the power rule. So it's y prime.
I got 40x over 7.
No, you're multiplying these numbers. So you see, this is the calculus. This is the derivative step. Did you divide each of these by x squared? See how it's a 2 this time? 8 right here. 8 minus 2 equals 6, and then 7 minus 2 equals 5. I think you just put 7 there or something. Hamad, are you there?
Hello. Yes.
Yes, you muted yourself or something.
Oh.
Hopefully you heard that. I can repeat if you need me to. 8 minus 2 is 6. That's why it's 5x to the sixth. 7 minus 2 is 5. These exponents here.
Yes.
Okay. And then the derivative is just like we've been doing. Like, I know you can do this step, but now we're throwing in other stuff to get to that step. So it's not as straightforward. It's not as just like, hey, do this. It's do a few things and then do this.
I don't know how I got y equals 40x over 7.
Well, you 8 times 5 or something, but you
Oh,
can't do
yes,
that.
yes.
Yeah, you
Oh.
can't do that. You have to simplify these first.
Okay, so I got this one. Okay, so 8 minus 2, which is 5x, y equals 5x over 6.
To the 6, yep, power of 6. Yep.
Yes.
3x.
Yes. To the 5. Okay. Then after that, y equals 30x.
Y prime. This is the derivative.
Oh, that's the derivative. Yeah, y prime. Okay, I have to write the y over y exponent 1.
It's really it's like a tick like that.
Okay.
There's other notation here, dy, dx. I'm trying to not like f prime of x.
And that means prime, y
Yeah,
prime.
yeah.
Okay.
These all mean the same, but like I don't want you to get caught up in notation.
Oh, okay. 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 I got it.
Okay. All right, so let's do another example here. Let's go back to something more straightforward. Let's say it's minus 3x to the fifth plus 3 over x to the fifth. So there's no simplification needed, but you may want to rewrite this. Rewrite as 3x to the minus 5, because when you bring this up, okay, it becomes a negative exponent. Because when it's in this form right here, when you have this form, this line, you can use the power rule.
Three x. Okay.
Okay, so your derivative here, this is y prime or dy dx or f prime of x or ddx, is minus 15x to the fourth minus 15x to the minus 6.
Yes.
You subtract 1, subtract 1. So see, you have no problem doing this. It's just getting to this step that we have to work on. And that's pre-calculus, college algebra stuff. Okay. Let's try another example here. Let's say y equals 2x to the minus 4 plus 5 over x to the third. That's a 3.
I'll do that.
Try that on your own. It's just like this one. I mean, but it is different numbers.
Okay, is that a 3 or a 4?
3,
Okay.
and that's a 4. Sorry for the bad writing.
Okay.
We need to make that better. 3.
Wait. 15. Okay.
Okay, you got your answer?
What?
Do you have your answer on that?
Yes.
All right, here we go. So it's going to be, give you the final answer here. It's going to be minus 8 x to the minus 5, y prime, minus 15 x to the minus 4.
Yes.
Great. All right, let's try another one here. So I can give you different forms. I can say f of x equals minus 3x minus 3 over x like this, okay? So the first one here, what's the derivative of minus 3x? Okay, remember that's to the power of 1, just the negative 3, right? And
Yes.
this right here, you write as minus 3x to the minus 1 power. So when you take the derivative,
Which is -2.
plus 3, but you subtract 1, x to the minus 2. Like you said, perfect. Okay. All right, so now here's a new rule, and this gets confusing, but we'll try not to make it so. If y equals a number, the derivative is 0.
Okay.
Okay, so let's say y equals 5, y prime equals 0.
Okay.
Let's say y equals pi. The derivative is
0.
0. Okay, let's say y equals pi squared times 3 over the natural log of 2. All of this
0.
is a number. Yeah, is a number. Now, I bring it up now because what often happens is students get confused. I tell them that y equals 4 plus 4x plus 4x squared. What is the derivative of a constant or a number? What is the derivative of a number? We just did 2 examples like that. What's the derivative of a number?
4.
0.
Oh.
See, the derivative, it's if it's a number, the derivative is always 0. Plus, what is the derivative of 4x?
4x 4.
Just 4. Very good. Plus, bring this down, 8x.
Yes.
Okay, let's do another example. Y equals 4 over x plus 4 plus 4x plus x over 4. These are, I guess, the 4 ones that are weird. Okay. So let's maybe rewrite this. So this is 4x to the minus 1 plus 4 plus 4x plus, now this is just 1/4 times x.
Isn't the 4 0? No?
We haven't taken a derivative yet. This is just a rewrite. Rewrite. And then now you can take the derivative.
Okay.
So now I want you to take the derivative.
It's 4x. No, it's
So you bring this down, right?
Yeah,
It's minus 4.
-4 x to minus, yeah, plus 0.
Yep. Plus.
Right. Oh. Plus 4.
Very good.
Plus. Wait, how did you do from x over 4 till 1 over 4 times x?
There's really a 1. There's really a 1 here.
Oh, okay.
So you can write it, and so these are the same rule. These are the same. Like It's just a number in front.
Okay. How to do this? It's just 1/4.
Yes, very good.
Okay.
All right. Is this making sense? Are you getting it? Do you feel?
Yes.
Okay. Let me see real quick here. Let me see if I can find see if I can find some problems here that you might see on an exam. Yeah, okay. So let's look at a few of these other ones that I haven't covered yet. See if they make sense. So the first thing is that you can use other letters. Like it doesn't have to be X. X is just the letter we use in math, but you can take the derivative with respect to t. So here you're still going to use that rule. You're going to bring that 2 down, right? Like minus 4t plus 3 minus 0.
Yes. Okay.
So let me give you one. Let's say f of w equals minus 3w cubed plus 4w minus 5. Give me the derivative of that, please.
So it's -9w to the
Okay.
power of 2
Yes.
plus 4 minus
Yes.
0.
Very good. Okay, excellent. All right. So let's look at another one here. Okay, so this problem, we need to do a rewrite first. Okay, and I'm gonna write something here, and you tell me if this looks at all familiar and if you believe me. Do you believe that these are this becomes this? Do you see that? Like 5 times 1 is 5. The 2x squareds come together. Do you see that?
If I'm gonna do it, I was gonna do like 2x on the bottom, then no, like 2.
Yeah,
No.
it has to be this way though. Like this, that's why like you break this apart here.
Hmm.
And that becomes that, and then there's really a 1 there, and that becomes that.
Oh, okay.
Okay. No calculus yet, not yet. So this is x to the minus 2 power. Okay, so now you can do your calculus. Now you can do your derivative.
Okay.
So you take your y prime is 5/2 times -2 x to the minus 3 power. And then this is really minus 2 over 1. So you get minus 10 over 2. And that becomes -5 x to the minus 3.
Why didn't we do anything to the 5 words? Oh no, like okay.
We can, this was -2. Sorry, they came from here. Okay, so here's one to try on your own. It's really similar. Okay, it's really similar. In fact, I'll just put it right here next to it. Okay, and again, it's take the derivative. What is the derivative?
So okay. So y equals 3/2 plus
Not plus, times. That's multiply.
times.
Multiply, yeah. Maybe you meant that. I know English is not your first language, so
Yeah.
I understand how difficult
Uh,
this can be.
times 1 x. Okay, then y1, right?
We'll see how we modified this. Like we wrote x to the -2. We want to do the
Yes.
same thing here.
Oh, so before finding out the derivative, right?
Yes, exactly.
Oh,
Sorry,
okay.
I went a little too fast on that. Now you're ready to take the derivative.
Wait. So it's 3/2. Okay, so -4 times 3/2, which is what? And over -5, yeah.
Yep. So like -12/2, because you multiply the tops.
Yeah.
So then you're -6x to the -5.
I have to simplify the fraction.
Yes.
So I can't write the fraction as the answer.
No.
Okay.
Your instructor will be unhappy with you if you do that. Okay, let me give you another one like that. Y equals 4/3x to the 9th.
Where is it? Oh,
There it is right there. So try that one. It's just like the previous two that we did. Nothing different, nothing
okay.
special. Just
Okay, but what is -9 times 4/3?
you multiply the top 4 times -9. So
Okay.
this is what I heard. You have to sorry, let me rewrite this. -9.
Yes.
Okay.
Yes.
So it's -36/3
Okay.
y prime. So y prime is -12. Like that. All right. Do you want one more like this?
I understood.
Okay. Okay, so we're going to go back to one that we already kind of did. It's a review. We'll see if you remember. Okay, so you want to divide first. You want to divide each of these by x.
Okay. So
And I'll write it, but you can do the evaluation. So you subtract the exponents. Okay, like 3 minus 1 equals 2. So you get
Yes.
4x squared. 2 minus 1 equals 1. So you get 3x. And then now you're ready to do your calculus, to do your derivative.
Okay.
So what is your derivative here? F prime of x. What is your derivative?
8x plus 3.
Good. Okay, so another one. This one's slightly more difficult, but it's the same setup here. Like you divide and then you take your derivative. So let me cut that out there. Yeah, so give this one a try. It's a little bit different. So if you get stuck, I'll definitely help.
Okay. So is it like a plus 2x over 4 over x3 plus or minus?
It's minus x
Minus.
over x cubed. Yeah, and that's a
Minus.
1 there.
Yes. Okay, so wait, I'll do it. Okay. So one, two,
So check this line that I'm putting an arrow at, because it's really important that you get this result here before you take your derivative.
yes, I did it.
Great. So your derivative,
The derivative 2 plus,
so remember there's really a 1 here. So it's -2 times -1.
yes, I did it.
Yeah. Great. Okay. All right. So now a new type of problem. Okay, so we're going to take the derivative of this. Now, this time you multiply first. You multiply and you distribute. This is before the calculus, no calculus yet. So this becomes 2x to the 4th minus 3x cubed. And this rule is you have x to the n times x to the m. It's x to the n plus m. So you add the exponents. So you distribute in. Okay, and now you can take your derivative.
I'm confused.
About this step?
Yes.
Okay, so this is a college algebra pre-calculus thing. Okay, so it's something you're supposed to know, like x times x is x squared, because x times x is x to the 1 plus 1. You add these top numbers.
Only the okay. So y equals 2x to the
Yeah, you add this 2 and this 2, you add this 2 and this 1 to get 3. Then you can take your derivative, but not yet. It's like the previous problem where you first divide and then you take a derivative. Here you have to multiply and take your derivative. So your derivative, and this is the easy part because you know how to do this, 8x cubed minus 9x squared. That's the easy part. You multiply, subtract, that's the easy part because you've done it.
Yeah.
Okay, so let's do another example. Let's say y equals x cubed 3x to the fourth minus 2x. So you're gonna multiply in. So this 3 with this 4.
I'll do it. I'll do it.
Okay.
Okay, I did all of it.
Okay, so your derivative is 21x to the sixth minus 8x cubed.
8?
2 times 4.
No. I did. Wait, I did negative 2 times 3. How?
There's a 1 here.
Where?
Well, it's not written, but it's known. It's known to be. So like when I write x has a power of 1. It has a 1 in front and it's divided by 1. Like these are all the same.
Oh, wait,
X.
I don't know what's my mistake. What did I do?
Well, did you get 3x to the seventh?
Yes.
Did you get minus 2x to the fourth?
No.
What did you get here? 2x to the third?
Yes.
But there's a 3 and a 1.
Where?
Well, I didn't write it, but it's known to be there. Like there's always a 1 here. Even if you don't write it, there's a 1. It's not a 0.
Oh, it's a 1. Okay, so I'm supposed to add them.
Yes, and that's what I was trying to show you over here to the right is that x doesn't have to have a 1. It could just be x, and you don't write 1x, but you could.
Yeah, okay. So the 4, then.
Yeah.
Okay.
All right, one more example. My virtual lessons are only 50 minutes because it's much more difficult. Minus 2x times 3x to the fifth minus 4x squared.
Okay. So y equals.
So the this is important. This is
it's negative 36x to the 5 plus 24x to the 2.
perfect.
Okay.
All right, so I'm going to email you these notes so you have them. And did you've really got to get signed up for the Pearson
yeah, but
physics.
I have my physics homework due tonight, but like I don't know how to do it. Could you help me with that?
I can't sign you up for Pearson. It asks for your name, your address, your billing, all that stuff. Like you got to go and click on the link.
On which link?
It's in D2L. It's under, when you click on the assignment for physics, it'll say.
Yeah, but because my laptop, there's no Wi-Fi here, so I can't like use my laptop. And I tried doing it by my phone. It doesn't work.
It asks you for like your name, your email, like all that personal stuff that I don't want, or I don't like. Maybe you get it. Maybe it's not due today. I don't know, but
the homework it's due tonight.
Okay. I can't sign you up. I mean, you gotta sign up for it. Like I can't do it. It's not.
if I get signed up, could you like help me with the homework?
Yes.
Okay.
Send a message over when you get signed up.
All right. Okay.
Okay.
Thank you so much.
Thank you. Have a good night. Bye now.
Thank you. You too.